This is going to be a video about solving differential equations that are first order and separable. That means the x's and the y's can be separated as opposed to inseparable where they can't be separated. So I have this quantity 1 plus x squared times the derivative of y with respect to x minus 2xy equals 0. So the first thing that you're going to want to do is you are going to want to separate the variables so you have y's on one side and x's on the other. But before we do that, I'm going to turn this y prime into dy over dx just so it's a little bit easier to work with. All right, next I'm going to put this 2xy on the other side just to kind of separate these variables a little bit. All right, so from here now, I'm going to get this 1 plus x squared over on the other side. So I'm going to divide this 1 plus x squared on both sides. So it's something like this. Okay, now from here, what I'm going to do is I need to get the x's and the y's on separate sides. So if you notice I have a dx on this side, well, I'm going to want to put that on this side, and this y right here, I'm going to want to put that on the other side. So what I'm going to do in order to do this is you see it's divided by dx, so I'm going to multiply both sides by dx. So that's going to cancel here. So now I only have a dy on this side, and then over here I have a y, so what I'm going to do is multiply both sides by 1 over y. Or you can divide both sides by y as well. It would do the same thing. Okay, now from here I'm going to simplify. So I have on this side 1 over y dy. If you notice everything that I canceled out, I put lines through here. You're going to want to do that to be as organized as possible. It's going to save you a lot more trouble in the long run. Okay, on this side I have 2x over 1 plus x squared times dx. Okay, so I have all the y's on one side and I have all the x's on the other side. Okay, so what I'm going to do next is I have to get rid of this dy and this dx because if you remember, the solution for differential equations has to only be in terms of x and y. So to get rid of those, what I'm going to do is integrate both sides. So do an indefinite integral of 1 over y and then an indefinite integral of this 2x over 1 plus x squared. Okay, well, the antiderivative of 1 over y is ln absolute value y plus c. Now because I'm going to have a plus c on this side and this side, I'm going to do a plus c sub y. So this is the constant of integration that happens when I do the antiderivative of this y right here. Okay, on this side I'll have a c sub x just to kind of separate the two. Okay, for this one, you should notice that you have a function on the bottom here and a function on top, and there's no quotient rule for integration. So what I'm going to do for this is I'm going to use u substitution. And that u, hopefully you can kind of see the pattern in terms of u substitution, that the derivative of this denominator right here would be 2x, which is the numerator right here of 2x. So it makes sense to put this 1 plus x squared in as your u. So I'm going to do that really quickly. So my u is equal to 1 plus x squared, and then from here, my derivative, du over dx, is going to be 2x. Okay, so I substituted for this bottom term, I substituted for this top term here with the 2x, and now I just need to substitute for that dx, so I'm going to multiply both sides by dx here. And I have du is equal to 2x dx. So everything is substituted here, so I'm going to rewrite it now. So it's going to be 1 over u du. Okay, from here, I'm going to take the antiderivative of this 1 over u, and it's going to be equal to the ln absolute value of u plus c sub x. Again, because it's the antiderivative of the x, so I'm going to put that c sub x right here. Okay, from here, I'm going to subtract the c sub y on both sides, but I'm going to kind of do that over here. So I have the ln absolute value of y is equal to the ln. Now I'm going to substitute my u back in here, so now it'll be the ln absolute value of 1 plus x squared plus c sub x minus c sub y. Well, these are both constants, so what I'm going to do is I'm just going to combine them to be just c regular. So it's just going to be ln absolute value of 1 plus x squared plus c. Okay, from here I want to solve for x and y, and what I can do is raise both sides to the base e exponent. So I'm going to say base e here and base e here, and that's basically going to get rid of this ln right here. The e and the ln are going to cancel out, so you're going to have the absolute value of y. Let me put some lines here. So you're going to have the absolute value of y equal to, and this is where it's going to get a little tricky. So you need to rewrite this to be e to the ln 1 plus x squared times e to the c. Because if you remember, if you do e to a plus b, it would be equal to e to the a times e to the b. So what I'm doing is just basically separating these out. So now we can simplify this value right here. So this e and this ln are going to cancel. And you're going to have the absolute value of y is equal to the absolute value of 1 plus x squared times e to the c. Now, e to the c is just some constant because it's e to some constant. So what I'm going to do is I'm just going to set this equal to some other constant a. Okay, so I'm going to just say it's the absolute value of 1 plus x squared times a. Now, the absolute value of y is kind of going to be assumed because the absolute value of this side. So I can actually just turn this into y is equal to instead of the absolute value. Okay, now this right here can only be positive because 1 plus x squared can't be negative. Any value that you put in for x, you're automatically going to get a positive. So actually the absolute value sign here is going to be redundant. So what I'm just going to do is move this a to the front and then just get rid of the absolute value. So it's going to be 1 plus x squared times this a right here. And that ends up being the solution to this differential equation. So that's solving a semi-complicated differential equation that's first order and separable. If you have any questions about anything in this video, let me know.